This is my top link video for interpreting 392. My name is Elisa Warren, and this is for my work sample number 1.
Okay, today, in your text for the last few days, you started to read the information that section review over humidity and condensation.
I think it's weird how he has a pen in his hair.
What we're going to do today is go through and look at those. The first thing you need to do is in your notebooks, I've got, I believe, 9.
Looks like an older classroom setting because of the computer or the PowerPoint that I see.
What I've got is a presentation here. PowerPoint, we're going to put it up here. It's not real dark because of the light, but you should be able to see it.
Well, if it's not dark, then maybe you should.
Words one at a time. Make sure you understand each one of those. So copy it down as we go. First word.
Oh, he put a paper underneath a PowerPoint, and now it's on there.
Cooling process by which water is changed from the liquid form, which is water, to the gas form, which happens to be water vapor. Thinking about evaporation, we've talked about several possibilities or examples of evaporation. We talked about oceans, and we looked at principles of desalination. What was one principle that we used in desalination as far as evaporation goes? Anybody remember? Danny?
Doesn't have a lot of facial expressions. Looks pretty serious when he's talking. It's very monotone and kind of boring.
The water evaporates and the salt stays.
Okay. Salt stays, evaporation, water rises to the top, runs down the side. You can collect that fresh water.
Has hand gestures, which makes it easier to understand.
The most important thing to know about evaporation is it's a cooling process. And we're going to do a little mini lab over here. That's
mini lab.
Look at that.
Like a science experiment or
a better chance to understand that it's a cooling process. And what you're looking at basically
to help us understand what evaporation means.
Taking water from its liquid phase and putting it to its gas phase. And there are probably 50 different variables that can influence the rate of evaporation.
Many variables that influence evaporation.
Other terms, the two major ones. We're looking at evaporation. And this is the second one, condensation. Basically, you can say that these two are opposites. You take evaporation, you take water in the liquid form, and you transfer it into water in the gas form.
That's really confusing that you take two things and you say that they're the opposite.
Water that is in the gas
that would be hard to
and convert
interpret.
that into water to the liquid. Condensation process in which gas
moves his
water,
hands a lot from going from his pockets to his hands to his holding his hands. Does it have a lot of eye contact with
a good example
people
of condensation? Or sometime when they've experienced what they thought was condensation.
He's asking a question to the classroom. He's done that a couple times now.
In the morning.
Okay, dew on the grass. If you happen to get up nice and early, and it depends on the environmental situation.
Takes a lot of brief pauses in his sentences to collect his
running
thoughts.
Barefoot through the grass in the morning, your feet might get wet. That's from dew or water that was out of the atmosphere.
He thinks that's a funny joke. That's the only time I've seen his tone actually change and get a little bit higher pitch.
When like it's cold outside and you breathe on the window glass.
Okay, that's one. Cold outside, you go up to a window itself, and you breathe on the window. You have, every time you exhale carbon dioxide, other gases.
His eyebrows have like gone up and down only a couple times. It doesn't have a lot of emotion.
It cools
while talking about
condensation. Another one. Right?
Like when you're cooking and the steam from the pan hits the lid.
Okay, that's one. You're boiling something, cooking something, you take the lid and lift it up, and there's water that's collected. Take the lid, sit on the stove, and then you have water that runs everywhere. Another really good example. You always.
Sorry, this is freaking out. Okay, no, it's back.
Okay. A picture from the book. Exactly.
Nah.
You take a cold glass of water, take it out, set it on a table or whatever. Especially sometimes you come back, and then there is moisture all around the outside of it.
Seems like a lot of
did-
dialogue between the teacher and the class rather
One time
than
I
him,
was on
you know, lecturing.
fourth grade. And I asked him, I told the principal, I said, got water on the outside.
Now he's talking
I want you to tell
about
me
fourth graders
how
and
it's
how
it
he
is.
had dialogue with
You can only
them.
tell me, or you can only ask me questions that end in yes and no. And we sat there for 45 minutes and asked me questions. Mr. Schnorr, no. Yes. No. I said no. Well, they finally came up with the reason why condensation takes place. Now, where we
Paces
know
back and
condensation is
forth.
water collecting outside of the cup. What I want to know is why.
Okay, well, why? Okay, so
This is my
what
question.
is?
TJ, what do you think? If I take this Pepsi can, and right now I can pick it up and feel it, it's got water on the outside of it. Why does this have water on the outside of the Pepsi?
It's like cooler on the inside and warmer on the outside. So it's like evaporating.
Like evaporated? Okay, he's got some good points, and right off the bat, he's got pretty close. What do we know about two things? First of all, this Pepsi, is it warm or cold? It's cold. When you take, example, condensation, and you take water from a gas form, or like water vapor, and you try to turn that into water in liquid form, what do you have to do with that water, with that water vapor?
Water
To get it to go
vapor?
from a gas to a liquid. It's the same thing you have to do to make it go from a liquid
He's looking
to a solid.
for people's facial expressions
Curtis?
after he's teaching.
You have to take the heat out of it to make it go from a gas form to a liquid form.
Okay, what's another way to say take the heat out of it? Cool it. You
He's
cool
asking
water vapor,
the
it turns into
classroom
liquid.
questions
If you cool
to
liquid, it turns into
instigate
solid.
a different answer
Why do you think
that he actually is
that
looking
the
for,
water
which is
vapor
a
in the
teaching
air
technique.
it's collecting on the outside of this Pepsi? Because it's cooler. What's that do to the air around the Pepsi can? It cools it, and the water vapor in that air around the Pepsi can cools and turns to water and collects on the outside of the Pepsi. That's condensation. And there are 100 examples. Everybody got this? We'll
So
talk about
100 examples. He did say 50 variables, so it sounds
Next
like he's
one.
pretty.
saturated.
Uh,
Term used to describe the air when it is at the limit for the amount of water vapor that it can hold. This one, you can use saturated to describe a great deal of it. The one we're looking at is the atmosphere. The air in the atmosphere will only hold a certain amount of water vapor. When it reaches a point where it loses its ability,
his tone is starting to
hold
get more
water
direct
vapor.
when he really
What
wants
does
to
it
make a
do?
point. It sounds like he's trying to
Yep.
stop and
it rains.
really emphasize it.
Or you get a rapid temperature change. Suddenly,
He's still pretty
the cloud
monotone, and his
can't
tone is
hold
pretty
much water vapor.
even paced.
rains.
But
Another
when
thing to
he wants to
use,
emphasize something, he's
describe
pretty.
saturated. Nice dirty sponge here.
Nice
Is this
and
sponge
warm.
saturated?
He has an example of a
Caleb?
sponge.
Why not?
Because there's no water in it.
Not
It
much
looks
water.
pretty dirty.
How could I saturate this? Okay. So it brings it to a point where if I tried to mop up a spill or something with this, that it wouldn't pick anything else up. It's got all these nice little air pockets in here that trap the
He's
moisture
talking
or
about
the
the
water.
air pockets in a
And
sponge, and
once
that
it gets
can
saturated, it can't
pick
hold
up
anymore.
messes
And it
and
gets to the point where it's saturated and hold it up, what will it probably
water.
do? It's going to drip. So it's only
He still
holding a
has the
certain
pen
amount
in
of water,
his ear.
and eventually it's going to start giving some of that off. Other
Moving
things
back
you can
and forth
describe
from
as
the
being
presentation
saturated,
slide,
a
which is
few days ago
pretty distracting.
or last week, the soccer field were saturated.
Went from a
we
couple
had
months
so
ago
much
to last
rain
week, which is kind of
Pretty extended period of time
interesting how
that
he
it
went
couldn't
from that
hold
time
any
frame.
more water. If ground gets to the point where it's saturated, what usually happens? Flood. The water can't go in the ground, it's got to run up on top. Usually run downhill. Like the video we watched last year, talking about those canyons and things up in Colorado and that tourist attraction over in England where they got 30
Tourist
inches of
attraction.
rain.
Oh, 30 inches of rain. Wow,
One
that's
day.
a lot. Only in one day?
Ground can't hold that stuff that quickly gets saturated. So that's that.
Wow,
We're
he moves
focusing
around a
on the
lot.
amount of moisture that the atmosphere.
Okay, so now I'm assuming a different
Next
term's
term.
going to pop up. Yeah, so it looks like
Term
humidity.
you're all familiar with. heard several times, I'm sure, humidity. Very simply put, water vapor in the atmosphere, or water vapor in the air. That's humidity.
Looking around for the classroom, looking
it
and
humid
making
today?
eye contact.
Yeah, very.
It's very humid
Raining
where
off
they're
and
at.
on, we're probably going to get rain again. So the humidity, or the water vapor in the air, is fairly high. What's one characteristic about humidity? What's humidity usually do?
Flattens your hair.
Okay. Those girls just hate it when their hair gets flat. Other thing,
He thought that was funny.
you go outside, and would you rather be outside working in the yard on a day that's 90 degrees?
It's the first time I
Celsius
saw
or
him
a day that's 90 degrees
smile
Fahrenheit?
in the last 10 minutes.
Yeah, it's sticky, muggy, it's not very comfortable. Sweat, usually, a lot more easily.
He's giving off
Days.
lists by moving his hand, which is interesting, even though he doesn't know ESL.
Next one. Term that you should see on the news or hear on a regular basis, relative humidity.
Now he's talking about
Measure
relative
of
humidity,
the amount of water vapor
humidity,
actually
excuse
in the air paired with
which
the
is like
maximum
hot,
amount that the air can hold.
and
at a
the air
certain
can't really hold a lot of that moisture, so it makes the air very
Measure of the
moist
amount
and
of water
gross.
vapor actually in the air paired with the maximum that the air can hold at a certain temperature. Now, when you look at air, this is the property we need to discuss. Air is made of gas.
He's taking a lot of
Oxygen,
more. He's taking more brief
carbon
pauses. It seems
dioxide,
like, which is
nitrogen.
interesting.
There are many gases you can put in. What you have to know is about the particles in the air.
He's
or the
doing
molecules
this,
at
like counting
different
off and listing
temperatures.
things, which is interesting.
Examples. Doing dishes. What water
I
usually
hate
works
doing
better
dishes.
than dishes? Cold water or hot water?
Hot water
Why does hot water work better than cold water?
kills the bacteria faster than the
What's happening to those water molecules in hot water versus cold water? It has
Go
to do with
faster.
speed. What?
Oh,
They
I got
move
that right.
faster. They're moving faster, so they're more
So
active.
helps the
to get
dirt get off faster. on the
Whatever you're
dishes.
trying to get off that plate or get it clean. If you take two sets of water molecules, one moving very slow, one moving very quickly, the ones moving quickly have more space between the molecules. The cold ones are usually kind of bunched up. The
Yeah,
warm
he's
ones
again
are
using
just
a lot of
all over the
gestures
place.
again, like
They've
going
got all
like
this
this and then
space
going like this,
between them.
which is interesting.
Now, if you look at air molecules, they're the same way. The warmer the air, the faster those air molecules are moving, and the more space there is between the air molecules. If there's more space between the air molecules,
Okay,
what
and the
does that
video
mean?
is at
You can
13
put
minutes, and this
more
is
space.
where I stopped it
Got it?
for my other friends stopped doing this.
Oh,
So
water
this
vapor.
is the
Water vapor.
end
Right.
of
The
my
warmer the air,
my
the
tab.
more
Thank
space
you.
it has,
Bye.
more water